I'm Anandan Dhanaraj. I'm happy to be here in Conf42 Machine Learning 2025. I'm a senior software engineer. I have spent several years in building a high performance microservices. I'm here to talk about how to build a high performance scalable data pipeline for financial domain. In today's volatile financial market, where millisecond can means million in lost opportunities, traditional financial data processing platform is failing to meet the increasing large volume of data processing in short time. This architecture explains how to build an high performance scalable data pipeline for the financial institution to handle millions of transactions in short period of time with exceptional performance. The challenges of modern financial data processing we categorized into volume constraint, latency requirement, and data heterogeneity. Volume constraint. Legacy system struggle to handle thousands of transactions in a second during normal processing time. Often it completely failing during market volatility even when volumes can increase by order of magnitude. Latency requirements. Modern trading platform operate in microsecond environment where even millisecond delays can result in significant monetary losses and missed opportunities for position adjustment. Data heterogeneity. Financial institution must integrate data from multiple formats like Swift, JSON, XML file, and in different delivery channels like FTP, MQ channels, Kafka topic, and many more, which creates complexity that compounds performance challenges. Let me explain this architecture of this data pipeline. Let's start with the canonical schema. Normalization is the very beginning stage where data represent in standardized format to enable the seamless data integration with cross-platform capabilities. Ingestion layer is collects and process data extremely quickly while having backup mechanism that automatically switches operation if the primary system fails, which have the retrieve capabilities. In the enrichment framework, raw financial data will be enhanced with additional information like security details, account details, and FX, and any conversion and the calculation will be done as part of this section. Storage layer. So once this enrichment is done, the data will be flattened that will be stored into our Oracle database with unique indexing and partitioning for each data sets. In the analytical consumption layer, we are using the advanced real-time visualization to generate dashboards using the predictive analytics with faster performance queries. Let me deeply explain about the canonical schema normalization. In the input format, multiple trading platform delivering data in proprietary formats with inconsistent field structure, different time zones, date time format. So this transformation engine is capable of dynamically mapping the field based on the predefined schema structure and which eliminates this input format issues. And validation layer, the schema validation is enforced to prevent from the incompatible data type and other formatting issue, and configurable exception handling ensure a data integrity throughout the pipeline. Standardized output, uniformly structured transaction with consistent identifiers and a normalized field enabling seamless downstream processing regardless of data origin. As part of the enrichment framework, the our enrichment framework incorporates multiple reference data to enrich the raw transaction into complete data endpoints. This helps to spend less time to analyze multiple platforms for different data points. Strategic data storage. We are using the Oracle database for the better performance. As part of the strategic data storage, we are first analyze while onboarding the data set. We will analyze the query patterns and data volumes will be for to analyze the load of the data. And partitioning will be done for all the required data set with advanced time series optimization. Custom design indexes and optimized query plans are used to better results. Our database architecture have dramatically reduced complex query response time in production environments. This strategy was engineered to optimally distribute load across multiple nodes for max availability, this achieving a 78% reduction in average query latency for a missed critical financial operation. So, mission critical financial operation. Auto scaling mechanism are auto-scaling mechanism that maintain consistent performance during market volatility, automatically adjusting resource when transaction volumes spikes during peak periods. Our predictive scaling algorithm analyze historical patterns and current market conditions to proactively provision resources before demand materialize, maintaining latency SLAs even during extreme volume events. The performance benchmark. Our performance benchmark showcases the architecture impressive throughput capabilities with substantial capacity to handle market-driven search when required. These metrics were validated under simulated market volatility conditions, matching historical flash crash scenario, ensuring robust during extreme events. Our architecture is able to process 300K transaction per minute in the normal scenario, but in the during the burst, it able to process 450K messages between the within 8 to 10 millisecond response time. The availability is 99.99% with this architecture. Our implementation case studies results is categorized into three sections like transaction processing capacity, system reliability, cost efficiency. Our implementation achieved a 450% increase in transaction processing capacity, enabling the system to handle significant higher volume without performance degradation. This eliminated previously common processing backlogs during market events. In the system reliability, unplanned downtime was virtually eliminated with a reduction from approximately few hours to under 3 minutes. Component failures now resolve quickly compared to the lengthy outages in legacy system, with operational recovery time improves from hours to minutes. Cost efficiency. Pre-transaction infrastructure costs were reduced by 68% through more efficient resource utilization and the elimination of redundant processing. Complete pipeline life cycle through acquisition to the consumption. So when the publisher is publishing the data into the data bus, our raw consumer is able to listen messages from the database. For each data set, we have the separate MQ channels to listen the messages. The ingestion layer is able to quickly read the messages from the database and it publish into the our internal processing layers. There we have the enrichment layer which transforms the raw data into the complete data set by invoking the reference data and enrich all the data endpoints. And once this is enriched, we are using the Oracle database, which is a Oracle database where the data is stored in flattened format, and also it able to perform like thousands of records in a second without compromising any performance. And we have and then we have the analytical layer. We are creating the dashboard using the predictive analytic with the past of performance query, so we will not see any lag in the dashboards. And key takeaways and next steps from this architecture. The, this presented architecture has demonstrated the ability to process hundreds of thousand financial transactions per second with sub-millisecond latency, providing that properly designed system can meet the demands of modern financial market. Implementation consideration. When it comes to the implementation consideration, organization should begin with the comprehensive audit of current data flows, identify the most critical performance bench bottleneck, and implement the architecture using an incremental approach that delivers measurable improvement at each stage. Architectural balance. Success depends on balancing multiple competing priorities like latency versus throughput, complexity versus maintainability, and specialized optimization versus flexibility. Adoption to change requirements. Future direction. Our research continue to continues into integrating machine learning for predictive scaling and anomaly detection, exploring graph database technologies for relationship modeling, and implementing zero downtime upgrade paths. Thank you for visiting this presentation. I hope this presentation helped to build a high performance scalable data pipeline for the financial domain. Thank you.